Hi everyone, my name is ZALDIVIA, and today I will be going to discuss the IUPAC naming of aldehydes and the other interesting aldehydes that can be found in nature. So first, we will know more about the aldehydes. Aldehydes contains at least one H atom bonded to the carbonyl group, and its physical properties exhibits the dipole-dipole interactions because of their polar carbonyl group. There are a lot of interesting aldehydes that can be found in nature. One of those is the ethanol, also known as acetaldehyde. It occurs naturally in coffee, bread, ripe fruit, and it is produced by plants as part of their metabolism. Next is the almond or the benzaldehyde. It is an aromatic aldehyde bearing a single formyl group with an almond odor. It can be derived from the natural resources, and it is widely used by the chemical industry in the preparation of various aniline, dyes, perfumes, flavorings, and pharmaceuticals. Next is the lemongrass or the citral. It might help to prevent the growth of some bacteria and yeast. It contains substances that are thought to relieve pain, swelling, reduce fever, and etc. Lastly, the cinnamon or the cinnamaldehyde. It is a food additive to enhance the flavor or odor of food products. Also, it is a herbal remedy. Now, let us proceed to the IUPAC naming. In IUPAC nomenclature, all aldehydes are identified by the suffix al. For example, in this structure, I will be going to give its IUPAC name by the following the steps on how to name it. The first step is to identify its parent chain containing the carbonyl group. So, in this structure, here is the parent chain. Second step is to number the carbon chain to give the carbonyl carbon to the lower number. So, here is the carbon 1, carbon 2, carbon 3, and carbon 4. Since we have 4 carbon, the parent chain is butane. So, we are talking about the aldehyde. So, we will change it as butanal. So, in butanal, we have here the parent chain, and we have here the substituents. So, we will write it. So, in first substituent, it has located to the second carbon 2, and another substituent is located at the carbon 3. So we will have dimethyl butanal. So here is the name of this structure, 2,3-dimethyl butanal. I have here another example. So, we will identify first the parent chain. So, here is the parent chain. Second step is to name the carbon chain. So, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So, we have a 6 carbons. So, the name of this is hexane. But, we will change it to the suffix al. So, it will become hexanal. we have here two substituents. So the first substituents is located at the carbon 3. So we have here the 3-ethyl, and the next carbon is located at the carbon 4, which is methyl. 4-methyl hexanal. So this structure name is 3-ethyl 4-methyl hexanal. For the last example that I have, I will identify its parent chain. Then, number its carbon chain. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8, and carbon 9. Since we have a 9 carbon, its well name is no name. But we will change its suffix to nonanal. Nonanal. And then we will identify its substituents. So we have here at the carbon 3, we have here methyl. So 3, and we have here another methyl into 6 carbon. So we will name it as 3,6-dimethyl nonanal. And that's all for the IUPAC naming of the aldehydes.
Hello everyone, I'm Leabel SALMORIN, and I will be going to discuss the IUPAC naming of ketones and the other interesting ketone that can be found in our nature. So ketones contains carbonyl group, and it exhibit dipole-dipole interaction because of their polar carbonyl group. They are known for its strong and often sweet smells. The ketone acetone, for example, is a common ingredient in nail polish remover. It is a colorless, mobile, flammable liquid and is the simplest ketone. Another example is 3-pentanone, which is a colorless liquid ketone with an odor like that of an acetone. It is mainly used as a solvent in paint and a precursor to vitamin E. There are also ketone groups in sex hormones like progesterone and testosterone. And then there's cortisone, an anti-inflammatory medication. Another example, the dexamethasone, a steroid that has been used to treat arthritis, severe allergies, COVID-19, and sometimes cancer. Therefore, ketones are very important, and a lot of organic chemists spend so much time trying to make them in more energy-efficient and non-polluting ways. In the IUPAC nomenclature, all ketones are identified by the suffix "on". For example, in this given structure, I will going to give its IUPAC name by following the steps on how to name it. The first step is to find the longest parent chain containing the carbonyl group. In this structure, the longest parent chain is here. Second step is to number the carbon chain to give the carbonyl carbon the lower number. Carbon 1, 2, 3, 4, and 5. Since we have 5 carbon, its parent chain is obviously a penta. Then change the E ending of the parent alkane to the suffix "on", and it will become pentanone. The position of ketone in this structure is attached on carbon 3, so we put 3-pentanone. And as you can see, we have 2 methyl group and it is attached on carbon 2 and 4. Therefore, the IUPAC name for this given structure is 2,4-dimethyl 3-pentanone. Next, we have here a line band structure, and it contains an alkane group. So first, find the longest parent chain containing the carbonyl group. Second, number the carbon chain to give the carbonyl carbon the lower number. Since we have 8 carbon, its parent chain is an octa. The position of our ketone is in carbon 4, so 4 on. And the position of alkene is in carbon 5, so we put 5 octene 4 on. We also have 2 methyl group, and it is attached on carbon 2 and carbon 5. So therefore, the IUPAC name of this given structure is 2,5-dimethyl 5-octene 4-on. So next, we have here the given IUPAC name, and this time, I will draw the structure of this given IUPAC name. So we have 3-isopropyl 4-methyl cyclohexanon. So basically, our parent chain is a cyclohexane. Ketone is attached on carbon 1, and I will put it here. In carbon 3, naka-attach si isopropyl, while in carbon 4 naman si methyl. So here's the structure of the given name of 3-isopropyl 4-methyl cyclohexanon. So next is the last example, and we have 6,6-dimethyl 2,4-cyclohexadienone. Another cyclohexane ulit. And now, meron tayong 2 double band of alkene. So first, I will draw a cyclohexane here. And put the ketone in carbon 1. May double band na naka-attach kay carbon 2 and carbon 4. And lastly, we have 2 methyl group attached in carbon 6. So here's the structure of the given IUPAC name of 6,6-dimethyl 2,4-cyclohexadienone. That's all, and I hope you all understand the steps on naming and drawing the structure containing the functional group ketones.
This is FULGENCIO from BS Biology 1B, and I'll be discussing to you the carboxylic acids. But let us know what it is first. So, it is an organic compound that contains COH made up of carbonyl group and hydroxyl group. Hence, the formula looks like this. On its IUPAC name, the carbonyl group C double bond O is always at the beginning of a carbon chain. The carbonyl carbon atom is always designated as carbon 1. The parent name is formed by changing the E end of the alkane to oic acid. What I mean here is from this to this. So moving to the example. So first, we need to identify where is our functional group. So this is our functional group, C double bond O. Then we need to highlight the longest carbon chain, include the functional group. Then step number 3, we need to calculate how many carbon in our chain. So our first one is from the carbonyl group. So we got 4 carbon in our chain, so it must be butanol, but it is, in this case, for our carboxylic acid, we need to change the ending of the alkane to the oic, so it's going to be butanoic acid. Carboxylic acid occurs widely in nature. Here are examples of substances that can be found in nature: stinging ant, vinegar, milk, butter, valerian root.
Hi, my name is Althea, and I am going to discuss about the amides. So what is an amide? Amide is a carbonyl group linked to a nitrogen atom. It is commonly found in nature and are found in substances such as amino acids, proteins, DNA, hormones, and vitamins. One example of an amide that can be found in nature is the penicillin. Penicillin is discovered by Alexander Fleming in a bread mold culture in 1928. Penicillin is known as an antibiotic compound and is used to treat streptococcus and other gram-positive bacterial infections such as pneumonia, strep throat, meningitis, syphilis, and gonorrhea. Another one is the Gleevec. Gleevec is an anti-cancer drug that is used to treat chronic myeloid leukemia as well as the variety of gastrointestinal cancers. Another one is the niacinamide. The niacinamide is a naturally occurring amide that is a form of vitamin B3 and is used to prevent and treat niacin deficiency, such as diarrhea, dementia, tongue redness, peeling red skin, and many more. Another one is the nylon. Nylon is a synthetic material that is made of amide. It has a wide range of application used in clothing, rubber tire, rope, thread, and many injection molded parts for vehicles and mechanical equipment. And the last one, the well-known natural amide is the urea, also known as the carb amide. It is a waste product of many living organisms and the major organic component of human urine, the urea. Now we are going to discuss on how to name an amide. One example is okay. So now let us first identify the amide. So this is the amide. And let's proceed to its parent chain. So there's number 1, 2, 3, and the 4. So this is a butane. But since it's an amide, it's a butanamide. Then, as we can see, there is a methyl bond with a nitrogen. And that is called the substituents. That is a substituent. That is a methyl is a substituent. So, we're going to write N-methyl and methyl butanamide. That is one word. And methyl butanamide. So how about if we have a benzene ring? So this is a benzamide. A benzene ring and an amide. How about this? So it is a benzamide. We have a benzamide. Then we identify substituents. There are 4 methyl, 2 bond here in the benzene ring, and 2 bond in the nitrogen atom. And N, 3, 5, tetra, methyl, benzamide.
Good day, everyone. Today we will learn about esters. I am Princess Bayan, BS Biology 1-2, and today I will discuss what is ester. It is an acid with one hydroxyl group and replaced by an alkyl group as in the substitution reaction of a carboxylic acid and an alcohol. Properties of esters. It is less than on alcohols and carboxylic acids and soluble in water. It has a pleasant odor and commonly found in essential oils and perfumery. Examples of esters. Ethyl acetate. It has a sweet smell and colorless liquid that is commonly used in nail polish removers, glue, and the caffeination process of coffee and tea. Ethyl propionate. It is a colorless liquid with a pineapple odor and commonly used as a solvent, flavoring agent, and has a fragrance of rum and alcoholic drinks. Ethyl cinnamate. Ester of cinnamic acid and ethanol, which are present in the essential oil of cinnamon with a fruity and balsamic odor. This is usually used in the preparation of plum and other flavors. Methyl salicylate and methyl ester of salicylic acid, colorless viscous liquid with a fruity, sweet, minty fragrance used in producing mint candies and products. Last is octyl attenuate, an organic compound of esters that is usually found in oranges, grapefruits, and other citrus products which are usually used for artificial flavors and perfumery. Nomenclature of esters. In naming an ester, first we should find the longest parent chain with double banded with the oxygen. It has a suffix word "ot." We can draw in here the sample structure of an ester. First, we should find the longest parent chain with a double bonded on the oxygen, and we can see it here. So we can start 1, 2, 3, and 4. This is our parent chain. It is 4, so it is butane. And add the suffix word "ot." So it is butanote. We can see the 2 carbons on the right side. So it is an eth, 1, 2, 2 carbons. So it is a ethyl because it is an alkyl group, ethyl. So the name of this structure is ethyl butanote.